So this example is a open spandrel arch bridge, like I showed in the previous figure. So this is a parabolic shape which has three hinges, two at the supports and one in the crown part. Maybe it is not, it is hard to see from this camera, but I can explain the function of the parabola, mean the equation of the parabola is y equal to minus 25 over a 50 square times x square. So this y is the function of the parabola or equation of the parabola. Then we have a deck slab, and on deck slab there is a uniformly distributed load which is 500 pounds per feet. Then we have a center line rise which is 25 feet, and this line is the spring line. This one is the center line rise. So that's 25 feet. And at this point at D, we have at point D, there's a 25 distance located from the point B. So in total, the span is 100 feet. In total, the span is 100 feet. So this parabola, this three-hinge type arch has a parabola shape and it supports the uniform. As you know, this load will try to bend the arch. See, if there is a central load, they will try to bend the arch. So there will be compression force will be inactive, and this bend will be resisted by the compression. So you have to understand in arch, the forces will be in compression. Okay. And this one is called the ribs. The member which transmit the load from the deck to arch. So we have to see, we have to prove that this parabolic arch is subjected to only axial compression at the intermediate point such as D. तो हमने ये प्रूव करना है जनाब कि अगर मैं कोई एक पॉइंट लेता हूँ लेट्स से D, तो जो फोर्स मैं कैलकुलेट करूंगा वो एक्सियल कंप्रेशन नेचर की होगी. So जो नेक्स्ट स्टेप फिर आपने करना है कि इसकी इसी डायग्राम को आपने बनाना है, free body diagram of the entire arch. So you see the reactions here, the vertical, and I have taken the arrow both inward. The reason is they will try to resist these two ends because this load is pushing the arch downward. So that's why they will provide the resistance in this direction. So the arrow is inward, CX and AX. So now it's the first step is to calculate the reactions. Calculate the reaction. So summation of the moments. summation of the moments counterclockwise are positive, equal to 0. So at this point, the Cy will produce a moment of anti-clockwise, so it will follow a sign of positive and will be multiplied with the momentum. Then we have this component will produce any moment at this point. Cx. Cx will produce any moment at this point.
No, sir.
Sir, counterclockwise. Save X, no, sir.
It will produce moment or not?
Not, sir.
No, the
Not,
reason. The line of action of the force passes through the origin, mean it has no momentum. So if the momentum is 0, there will be no moment. Now the 50 kilo, 500 into 500 uniformly distributed load into span, which is 50. It will be 5,000 pounds. So 5,000 pounds, 1,000, 1 kip is equal to 1,000 pounds. So sorry, 50,000. So it will be a 50 kip equivalent load at the ground. Now this 50 kip, which is at the ground, it will produce the clockwise moment. So it will follow a sign of minus 50 kip into 50 momentum equal to 0. So Cy is equal to 25 kip. जी समझ आ गया आपको?
Yes, sir.
बाद फिर आपने करना ये है to calculate, to have a reaction of Cx, you will consider the segment BC. Since there is a hinge, so we can consider this section there. So I'm going to construct the free body diagram, of the section BC. These are the ribs. And since the span is 50 feet, so the uniformly distributed load was 500. So if I multiply 500, so how much equivalent force I'm going to have from this one? Half of the equivalent load, mean 25 kip at the center. 25 kip. 25 kip. And at this point, there will be an horizontal component Bx and vertical component By. Here, the Cx and Cy. And the vertical distance from the spring line of the support to the ground part is 25 feet. It's 25 feet. Now, for this arch segment, BC, I'm going to take the moment, counterclockwise moment is positive, summation of moment about B equal to 0. So equivalent force of 25 kip, which is downward, this will produce a moment of clockwise minus sign 25 into 25 feet, half of the distance, half of this span, and half of this span is 25 feet. So the moment arm available here is 25 feet. Then 25 into 50. Reason the CY is 25 feet. So this will produce a counterclockwise. So I have placed a positive sign here. Then the CX, this will produce a, which one? Moment?
Clockwise, sir.
Clockwise. So it will follow a minus sign CX into the distance, the moment down is 25. This is equal to 0. So simple maths, CX is 25 kip. So CX is 25 kip and CY is 25 kip. Then summation of the f of x is equal to 0. Right side forces, you see, dx minus cx equal to 0. So bx is equal to 25 since cx is 25. So double underline, remember you have to double underline the result always. Double underline. Okay. Then summation of the upward forces. So By minus downward force 25 kip plus reaction force, which is 25. So it means By is equal to 0. By is equal to 0. Okay. Since 25 kip is at the distance of 25 feet from point B, and this point is the B as per our problem statement. Okay. So we know that the equation of the parabola is 25 over 50 square into x squared. We have to construct first the section BD free body diagram. So let's say it's the point B. And this one is point.
Sir, page above कर ले नजर नहीं आ रहा.
Okay. Now view is okay.
Yes, sir.
Right. So the arch will be that's the point D, B, and in this part the load is UDL. So the UDL load is 500 pound per feet. So what is the span here? 25 feet. So I can convert the UDL, which is 500, into 25 feet. It will result in a 12.5 kip. So it means the equivalent UDL load will be of 12.5 kip, and it will be at a distance of half of the span, which is 12.5 feet on both sides. There is a BX force, which is 25, and the BY is 0. So BX is 25. Now, using the equation of the parabola, which is minus 25 over 50 square into x square, we can calculate, okay, we can calculate the y value if the x is 25. If the x is 25. So if you substitute the value of x, what is the y value at x when it is 25 feet? Will be y minus 25 in over 50 squared into 25 squared. So it will result in a value of 6.25. As a minus sign, since it is below the point P. So this point D from the crown is located at a distance of 6.25 feet. Now, if I want to take the slope, and so before I calculate the slope of the segment, I have to show some reactions as well here. There will be a shear parallel to the section of the arch is BB. Then there will be a normal force which will be inward. The reason I'm showing is compression. So the axial force in the arch is the compression in nature, and it's normal to the section of the arch. Then there's a moment MD counter. So to calculate this axial force, which is compression in nature, I have to utilize the equation of equilibrium. Now, to utilize the equation of equilibrium, I must have this angle. the angle, which is the theta. Now to calculate the theta at this point, I will take a tangent here, and the slope of this tangent is equal to tangent theta, which is dy by dx.
Sir, we can जो सर मोमेंट है वो ऑलवेज एंटी क्लॉकवाइज टेकन करेंगे.
Yes, I took this moment as anti-clockwise since I want to take the benefit of positive value.
Okay, sir.
Okay, I have not reversed the direction outward for this axial compression because theoretically it has to be axial. So that's why I have taken the arrow inward the arch. So x is equal to, at a distance of 25 feet, the slope of the tangent line is equal to tangent theta dy by dx. And what is the y? The function is the derivative of this function. इसका derivative क्या होगा? 2 into 25, 50.
50, sir. 50 divided
Over 50 square into x.
x.
Okay? And the x is 25 feet. So it will be minus 0.5. So the theta is equal to tangent inverse of minus 0.5. It will be at minus 26.6 degree. So this angle is 26.6 degree. You see, minus sign, this angle is below the origin. So once you calculate the theta, now to calculate the unknown, which is ND, we have the reactions and the loading at this point. The unknown is moment at point B, then the shear force at point D, and the normal, which is axial compression force to the arch. So you will apply the equations of the equilibrium. The first thing is summation of the horizontal forces is equal to 0, and horizontal forces are equal to 0. So it means 25, the horizontal force 25 kip minus ND. ND is the normal axial compression force. It has a you see, it has a horizontal component in this. Sorry, the horizontal component, the direction of the horizontal component will be reversed because it's already in this. The arrow is inward. So the horizontal component will be this in this direction, mean minus axis, and vertical component will be upward. So 25 ND cos of 25 cos of theta 26.6 degree minus shear VD